Hey guys, welcome back to another installment of Data Structures. So, in the previous tutorial, I talked about what a stack was and different implementations of it, either with an array or with a singly linked list. And now in this tutorial, we will implement the linked list. Linked list, the stack. So this is like my fifth time trying to make this video, so I've already have this the project made. So if you don't know how to do that, just right click on your solution explorer, go to add and new project. Make sure you create a console project and an empty project. Okay, so I am going to use this node class from the previous one, from the linked list, because it's still pretty much the same thing. We're just going to be storing data, and we're going to have a pointer to the next node in our stack. We're not really going to be using display, but everything else we are going to. And it's still going to be a templated class. So let's move on to our stack. See right there. It's too big right there, should be okay. So let's start off by putting the header comment. Wulfers. And let's do the date. 16. Happy New Year's, by the way. Hope you guys had a great time. I know I did. I was moving. Anyway. Okay, so implementation with a linked list. And then we can put here what functions. Then this one is gonna insert data to the top of the stack. Then we got pop, which removes data from the top of the stack. Then we got peek, this one returns the topmost data from the stack. It's just like a little refresher on what we went over last time. Okay, and then we can have a clear function. Just clears the data, clears all data from stack. And yet another function. Actually, this one's going to be the Boolean. Check if it's empty or not. Returns true if empty. false if not empty. And let's see what other functions. Maybe we can have also a function to return the size of the stack. So you can just say get size here. Returns size of stack. Okay, that should be it. Oh, okay, so for those of you who are not familiar with Pragma once, if we do not have this in our header files, or it's pretty much the same thing as this. So if we don't have this or this in our header files, if we try to include these files multiple times in our project, the compiler is going to not like it, and you're going to have errors and you won't be able to compile. So we need those parameters right there, those directives. Okay, so let's create our class. And let's not forget to include our node here. Okay, so the first thing we want to do is have the stack what do you call it? Constructor, there you go. And let's have our head, since remember, this is an implementation of a stack using a singly linked list. And we only need the head. We don't need the tail this time, because we only need to know where data starts from, which is the topmost area of the stack. Since we're not going to be doing anything with a tail or anything like that. Okay, and the other one is actually integer. This one is going to handle the size of the stack. And then here I'm going to initialize these to a default value with a initializer list, which I did it differently on the other one. I actually went and did it inside here. You can do that if you want, but I find it better with this. I'm not really sure if there are any benefits of doing this. I will try and research that and let you guys know if we do have any, if it's better to do it this way than the other way. But I like it this way better. Not sure why. Okay, initializing everything. Then here, we're going to call the clear function to remove everything. If we have anything left over in our stack. So, first thing is going to be the push. It's going to have T data. And we'll implement it in a bit. Then pop, and then peak, then is empty, and then clear. We're just setting up the skeleton for this, and then we'll fill it out in a bit. And last one is the get size, not get clear. Get size returns an integer. Okay. So let's start with push. So the first thing we want to do is we want to set up a temporary node and fill it out with the data. So data and then little pointer right there. Then we want to check if head is, if we have something in the head means that we that means we're not empty. So check to see if stack is empty or not. And if it's not empty, we are going to first set the next pointer to the head. So since we are putting everything on top, meaning in the front of everything else, we have to let our new node know where the rest of our list is. That's why we are linking it first to the head. Otherwise, if we don't do this and we set the head to temporary node, we'll lose everything else and we will have a leak in the memory. So after we set the next node for the temporary node, we're going to set head to temp. Okay, and then an increase size right there. So if it is empty, the only thing that we have to do is set head to temporary and increase the size, and boom. So that's our push function. Can go ahead over here in the destructor and color clear, so we don't have to come back here. Next, pop. So we got to remove the first object, and first we have to check if we have an empty structure. If we do, we don't do anything. If we do not, if it's not empty, then we do something. So the first thing we want to do is store our head in a temporary temporary pointer or variable. After that, we want to set the head to the next node inside. So we are shifting one over, and then we can delete temp and decrease our size. Store tab element in temp. Go to the next node on the stack and delete the node. Decrease size. Okay, that's pretty much it for pop. Now, peak. This one is pretty simple. All we have to do is return the head data. But first, we are going to check if it is not empty. And all we do here is, actually, we don't have to do that since we can use the is empty. That's why it is there for. So all we have to do here is return the head get data. Boom. And then here we can check. We can have two checks here because you never know what's going to go wrong with the size. We might forget something. So first we want to check that the size is greater. Actually, if the size is less than or equal to 0, to say 0, and our head is, we don't have anything in our head, then return true. Otherwise, we return false. So if is empty, return true. Otherwise, false. And the last one, oh, actually we have two more. But the next one is the clear function. So this one is the same, is going to be the same function that we had in the destructor for our linked list. So what we have to do first is, as always, we check if we have something in our head. Then we create a node, and we call it current node, which is going to be the topmost one here. And then we do a while loop. So as long as the current is not null, if we haven't reached the end, then we're gonna store here. We're gonna store the next pointer in our next. That way we know where our next node in the list is when we delete our current. Okay? So here we delete current node. We don't have to worry about anything because next is has got the rest of the list, and we just loop until there's nothing left. And do not forget to increase the size of your stack. And we set head to null. Okay, so that's that for this one. And last but not least is the size. We just return size, and that's it. So I'll go over it once more before we end this session. So pragma ones, make sure you don't sure that the compiler doesn't include stack.h more than once on memory. Otherwise, it's going to be like, what the hell? There's too many of them. I don't know which one to choose because it's stupid. Then we include our tnode header file so we can use our node class. Then we set the template class so we can have it dynamic with different data types and still use the same code. Then we create the stack class. Inside of the public, we have our constructor, which initializes, sets up default values for your variables. That's all the constructor is supposed to do. Now the destructor is supposed to clear and return memory back to the OS, so we don't have memory leaks. And that is what this is doing here. Push just inserts the data into the top of the stack. And the way we do this is first we have a temporary variable, and we set up inside of our constructor or our node class, we have we can pass in parameters. We can pass in the data and to store it in the node and the next pointer. And in this case, we don't want to store any node here. We just gotta put it null pointer. And then we check to see if the head is empty or not. If it's not empty, then we set the next pointer of the temporary node to the head, so we know where the rest of the list is before we switch the head pointer to point to the temporary node. And then we increase the size. And if it is empty, then we just set the head to temporary node, and we increase the size as well. Pop. This one removes the topmost data from the stack. The way we do this is we check, as always, if the head is empty or not. If it is not empty, then we store head on the temporary node. Then we switch head to the next node on the list, and then we delete temporary node, and we decrease the size. The reason we first put head on the temporary node is because if we don't do this and we just delete the head, we'll screw up everything and we won't know where the rest of the list is, and we'll have memory leaks. Peak returns the topmost data of the stack, stackle, and we just return, well, yeah, we just return the data. We get the data from the head, and that's it. Boolean, is it empty or not? Returns true if empty, false if not empty. So the way we do this is we check if the size is 0 and there is nothing in the head, then it's true, it is empty. Otherwise, it is false. Clear clears up the remaining data from the stack. Yeah. So first we check if we are empty. Store head on current node. Loop while we haven't reached the end of the stack or list, and then store the next pointer in next, delete current node, and set current to next to repeat the whole process again, and decrease size of stack. And this one just returns size of stack. Okay, and that is pretty much it for this node class. Hope you guys liked it and learned a bit more about data structures. If there is something you guys need to clarify for me to clarify for you guys, please comment below, ask questions, whatever. If you guys want to see something done, you guys can post it also on the comments. If you guys liked it and this is your first time or second time seeing this and you have not subscribed, please do. You don't have to, but you should. Now, yeah, so I'll see you next time. On the next tutorial, we'll actually use this stack class and make a program and see how what sorts of things we can do with a stack. All right. See you. Thank you. Have a great day.